Hey everyone, we'll be discussing my project today for my Biomedical Technology of testing photopolymer resins for biomedical applications. The initial design stage of this project was essentially I was given the options of multiple resins, and from there I chose the resins that I would 3D print in and sort of made an application based off of that. The whole purpose of the design was to see if there was any changes that could be made in the industry standards for the mouth mold and for the ball and socket joint. My whole goal was to improve the movement of a joint prosthetic, and if I had enough time, maybe analyze any other materials that could be used. On the next slide, I'm just discussing how I did my actual modeling in Inventor. It was just a simple spear and rectangular base, and for the cup of the spear, I just extruded it with the dimensions of the solid spear. Here we have the final product of my ball and socket joint. It's printed in PLA white with a 10% infill, a shell count of 2, which refers to the layers on the outside, a layer height of 0.2 millimeters. The total weight of this was 60 grams, including the initial dental mold, and the cost is pretty cheap. So in future instances where you did want to print another type of biomedical application in this material, it wouldn't cost you too much. For the ball and socket joint, my research limitations initially was the cost of the Formlab resins. When I printed my dental mouth mold, which you'll see later on in the presentation, I wasn't anticipating that when you print it in 100% fill, the cost would be much more. And so I was planning on testing 3 other resins, which would have brought me to a large price. Another thing would be when doing these joint prosthetics, you have to consider age, weight, and lifestyle of the individual that's going through this procedure. The last 2, biocompatibility and durability, would be in reference to me researching those materials that I was discussing earlier on, if I did have enough time to. Before beginning the process of doing the dental mouth mold, I wanted to get a different perspective from someone already in the industry. So I reached out to Becca with Abdoni Orthodontics. She is their 3D specialist. So she does all the 3D printing for the retainers. The first question I asked her was, what ways did Abdoni utilize 3D printing and what type of materials they use, and she did confirm that they do use it for their retainers, and the type of resin they use is called photo resin, and it's associated with this machine called Julie, or the brand Julie. I asked her what type of pros and cons were there that comes with using this method. She said the pros were the retainers come out very, very fast. Scan to print is almost essentially the same thing, which means the scan they take of the mouth is almost like 100% accurate to what's being printed out. It's very cost effective. The only con she did notice would be that the material they use isn't resistant to heat, so they can't really do too much adjustment or be in a temperature where it may melt the resin. For Becca, the final question I asked was, what do I anticipate the future uses are of 3D printing in the dental industry? To which she responded, with retainers, you have to, of course, do the scan of the mouth and then it'll print out. So she thinks in future cases, you won't have to do any type of scan. The technologies will just be able to 3D print automatically. Moving on to the next slide, you will see my initial 3D print of the dental mouth mold in PLA white, as well as the 3D print in the dental SG resin. Moving on to the curing process of the dental SG resin. When the dental SG resin is initially printed with, it comes with sort of a sticky residue on the item that's being printed, and so I was informed to soak it in alcohol for 5 to 10 minutes. I did the 10-minute mark, and at that point the residue was all gone, and then I also saw on the Formlabs website, if you place it in sunlight, it'll transition colors and hopefully become a clear color. For me, it took 3 days to even get to the second stage of the process, and so it's still curing I will hopefully upload my final results before the end of this semester. For future experiments, I would love to test on other photopolymer resins for the joint prosthetics. Again, like I said in the beginning, the cost was way more than I would assume I would have anticipated in results. Also, for the dental SG resins, I would look more into the surgical applications for it. When I printed my mouth mold out, I was aware that it did come with surgical. The purpose of it was for surgical uses, but I don't really know too many surgeries in the dentist industry, so maybe next time I could partner with someone who's already in the dental field and see how they feel about it. Also, maybe researching a different material for retainers. I know for my retainer, it comes with this plastic-like structure, and it is resistant to heat, so that's a good thing. And then finally, I would analyze the industry results on how they feel about these Formlab resins and to see if the testimonial from the previous slide is actually accurate. Thank you guys so much for watching. This was a great class, and I hope you enjoyed my presentation.